In this video segment, we are going to take a look at the third and last of the solution concentration expressions that you're responsible for knowing and being proficient with. And that is known as molarity, symbolized with a capital M. Now, the definition of molarity is moles of solute divided by liter of solution. It is very important that for each of the concentration expressions that you're responsible for knowing, that you understand the exact definition of that concentration expression and how to calculate it properly and use it properly. I've indicated that molarity is a very important concentration expression for doing stoichiometry calculations. And it's obvious when you look at the definition why that would be the case. We see that moles of solute is right there in the definition of molarity, so that will take us quickly to information about moles of solute needed to go on and do the rest of a stoichiometry calculation. Just looking at the dimensional analysis, we can see that if we take a molarity, defined as moles of solute over liters of solution, and multiply by a volume of solution in liters. So molarity multiplied by a volume of solution in liters. Looking at the dimensional analysis, the liters of solution cancel. We calculate moles of solute, and then we can go on and do a stoichiometry calculation if desired, or we could take that moles of solute and calculate a mass of solute from that, if we have, of course, molar mass information, or we could take moles of solute and calculate number of objects of whatever it is we're talking about, atoms, molecules, ions, formula units. We could do that calculation if we used Avogadro's number. So being able to calculate moles of solute by taking a molarity and multiplying it by a volume in liters enables us to do many useful things in the field of chemistry. Let's take a look at a couple of example molarity calculation problems. In this first example, you're asked to calculate the molarity of a solution made by dissolving 32.6 grams of sulfuric acid in enough water to make 400 milliliters of solution. What would be the molarity? Now notice right away that these units, grams of sulfuric acid per milliliter of solution, would be excellent units to directly plug into a mass volume percent calculation, but we are asked to calculate molarity, not a mass volume percent. So we're going to have to do some conversion factor work with these units to get them to be in the form of moles of solute over liter of solution. So tackling the problem, we're going to need to be able to write the chemical formula of sulfuric acid using our nomenclature skills. Chemical formula of sulfuric acid is H2SO4. We are also going to be able to, or need to be able to calculate the molar mass of sulfuric acid from that chemical formula. We need this molar mass to convert grams of sulfuric acid into moles. So looking at our periodic table and adding up the atomic weights of 4 oxygen, 1 sulfur, and 2 hydrogen, we come up with a molar mass of sulfuric acid of 98.08 grams per mole. And now let's see how the dimensional analysis works to be able to calculate the molarity. So here is our mass of sulfuric acid, the 32.6 grams. We need to take that gram amount and convert it into moles, part of what is needed for that molarity calculation. So 32.6 grams of sulfuric acid, and notice how I'm using the molar mass. I'm using it in its inverted form so that grams of sulfuric acid are in the denominator and cancel with grams of sulfuric acid that are part of the 32.6 value. If I stop my answer right now, I have moles of sulfuric acid in the numerator, which is exactly what I need. I am halfway there. Now in this next step, I am going to take the volume of solution, the 400 milliliters, and show a division. This is how you do a division, lining up the units properly for dimensional analysis. 1 over 400 mils is a division by 400 mils. But that unit of milliliters is not the unit that we need for a molarity expression. So in the last step of this calculation, I'm converting milliliters of solution to liters of solution, something that we've practiced many times throughout this semester. So notice, according to how the dimensional analysis is working, our milliliters of solution is canceling, and we are left with liters of solution in the denominator, exactly what we need for a molarity calculation. So taking our calculator and working through the calculation, double checking and making sure that our answer is the correct answer. I hope you are doing the same. Looking at our setup, I see that my answer should have 3 sig figs. So I am expressing the molarity of this solution as 0.831, 0.831 molar sulfuric acid, representing the molarity with a capital M. 0.831 molar sulfuric acid solution. Let's take a look at our second molarity problem. How many moles of calcium nitrate are present in 125 milliliters of a 0.570 molar calcium nitrate solution? The key to solving this problem is to be able to take that molarity, the 0.570 molar calcium nitrate, and write it like a conversion factor. Based on the definition of molarity, 0.570 molar calcium nitrate is equal to 0.570 moles of calcium nitrate per liter of calcium nitrate solution. So we've taken this molarity and written it as a conversion factor, the form it needs to be in for use in our setup. So looking at this calculation, here is a volume of solution in milliliters. We need to convert that to liters to correlate with the molarity unit of volume. So taking 125 milliliters of solution, multiplying by 1 liter over 1,000 milliliters of solution, I just converted my volume from milliliters into liters. I now have a volume of solution in liters. And now I'm writing my molarity as a conversion factor, the 0.570 moles of calcium nitrate per liter of solution. My liters of solution are canceling. The only unit left now in the problem is moles of calcium nitrate. So this setup is showing that if you take a volume in liters of solution and multiply by molarity of solution, you calculate moles of solute. So let's double check and make sure that our setup and answer are correct. So quickly going through the calculation, I am calculating with 3 sig figs according to the numbers involved in the setup, 0.0713, rounding up to 3 in the 10,000th place, 0.0713 moles of calcium nitrate, the answer to this problem. Multiplying volume in liters by molarity of solution gives us moles of solute.